Hello friends, welcome to a new video. Today we'll be discussing briefly regarding graph data structure and its applications. So which type of apps or websites come to our mind when we speak about graph? Here are some of the prominent companies that actively use to manage big data and efficiently process it. So let's consider an example of Uber ride where passenger books the ride and then we need to ensure that the shortest possible path is displayed on the screen of cab driver, which helps the passenger to reach his destination in shortest possible time. So this can be achieved using weighted graph where we can set some nodal points and the nodal points will have distance can be calculated between them and thereby we can figure out the shortest possible route. So here's an example. A graph data structure is powerful tool in computer science to represent relationships and connections between objects. It's essential in various fields, varying from social networks to navigation systems, flight, and recommendation engines. So here, this is an example of a social network based graph where Emma is friends with Raj and Sam as well as Nick and Anna, and Raj and Sam are indirect friends of Nick and Anna. So, using this relationship, we can easily figure out that there is a high possibility of Raj and Sam already known to these two friends. So, we can then recommend them to add to each other's network. So, this kind of relationships is utilized by majority of social networking sites such as Twitter, Facebook, and LinkedIn. So the objects here are termed as vertex or node, and the the line that joins them or connects them is termed as edges. So there are 5 edges in this graph, which are connected to the vertices, and vertex is also called as a node. So that's an example of social network graph. Now we move on to how to represent graph in form of adjacency matrix or adjacency list so that it allows us to utilize it in our algorithms which we'll be seeing further in upcoming videos. So as far as matrix is concerned, so we can first figure out the total number of vertex that are present in our graph. So here there are 4. So we can have a 4 by 4 matrix, and then one by one we can start whichever node is connected to other nodes, we can mark it as 1. So for A, in this case, A is connected to B, C, and D. That's why we'll be marking it as 1, and this will be left as 0. Then for D, it is connected to A. So D will mark only 1, and it is not connected to rest of the nodes. Then again for B, if you see it is connected to A and C. So if you see here, B will be marking for A as 1 and C as 1, and remaining will keep it as 0. So this is how we represent a graph in form of a adjacency matrix. Similarly, we can also represent a graph in form of adjacency list. So this is one of the common ways we maintain a graph. Here is an example of undirected graph, and all the nodes are connected to each other. So we need to maintain 2 lists here. One is the list of vertex and other is the list of nodes that the individual vertex are connected to. So in this case, if you consider 0, then 0 is connected to 1 as well as 2. So the list will have both the nodes present. Then similarly for 1 is connected to 2 and 0, so 0, 2 and null, and then similarly for vertex 2. So this is how we store the graph in form of a adjacency list, and it will be beneficial when we try to use some algorithms on it. And finally, coming to the weighted graphs, this is also a very popular graph format where we want to, let's say, reach our school, and a student is now currently located at his home. So we can see that the shortest path to reach school will be from home to subway and subway to school, because the distance between these two nodal points and these two nodal points is about, let's say, 2 kilometers. But if you consider any other path, let's say this path 1.8 plus 1.5, which is greater than 2 kilometers. And similarly, even if you go like this, or if you go through the gym and to the school, all of the nodal points are not as efficient as this one. So in this way, the weighted graphs are very beneficial when it comes to any navigation system, or any kind of ride apps, or food apps, delivery apps. So all of these will use weighted graph to find the shortest possible time to reach its destination. So in the upcoming videos, we'll be understanding how to traverse graph in vertical or horizontal way. Thanks for watching the video.